Okay, today we're doing day 2 of Unit 5, and it's all about finding minimum and maximum values of quadratic functions. Okay, so this entire unit being polynomials, where we begin with quadratics because that's one of the simpler forms of polynomials. So um, let's get to it. Find the minimum and maximum values. As we talked about last time, if we have a parabola, the minimum or maximum will always be in the same place, the vertex. Now, how do you find the vertex? The quickest way, if it's not in vertex form, is remembering that b is equal to, not b is, oh my goodness. X is equal to negative b over 2a, excuse me. So once we have that x coordinate, negative b over 2a, then we can get the y-coordinate just by plugging that in to our function. And remember, there are two forms of this function. If it's quadratic, standard form would be ax squared plus bx plus c, that is standard form. Or we have vertex form, which is f of x equals a times x minus h squared plus k. For standard form, the information we get directly from that is about a. If it's positive, then the parabola is opening upwards. If a is negative, it's opening downwards. And also C gives us some information. Do you know what it gives us? The y-intercept. For the vertex form, it's really nice. A is included, exact same number. It's either telling us if the parabola opens upwards or downwards. And then H and K, remember, is the vertex, which we talked about last time. Okay, so for example 4, we have a parabola. It's in standard form. It's determining whether the function has a maximum or minimum value, then find that value. Okay, this is our a value, which is positive. Therefore, this parabola is opening upwards. F of x has a minimum. To find that minimum value, we're going to use exactly what we were talking about before. X equals negative b over 2a. So x equals negative 1/2 over 2 times 1/4. And that works out to be -1, I believe. That isn't the minimum value of our function. To get the minimum value, I now find f of -1, which is 1/4 minus 1/2 minus 1, which gives us, what is that, -5/4? -5/4. So a perfect answer for this would be f of x has a minimum of -5/4, and then you may want to write at x equals -1. That at x equals -1 is kind of optional because it's not asking us where that minimum is. It's just asking us for the minimum value, which is -5/4. We'll do the same thing for b, and feel free to stop or pause the video at any point, or rewind, of course. Not rewind. You know what I mean. But this, we can see that a, in this case, is negative. Therefore, this parabola is opening downwards. So f of x has a maximum. How do we find it? Oh, it's at the vertex. So we start with x equals negative b over 2 times -1. So we have 12 over -2. That gives us -6. That's where it is, but we're looking for the max. So we plug that in. F of -6 is equal to -6 squared. Like, be careful when you're doing these, please. -12 times -6 minus 9. This is -36 plus 72 minus 9, which is, I believe, 36 minus 9 was 27. Yeah, so this has a max of 27 at x equals -6. That gives us all the information we need there. Moving on, determine the quadratic function with a given vertex and additional point. This means I need to find all of the variables, not the x and y, but the a, b, and c if we're doing standard form or the A, H, and K if we're doing vertex form. My recommendation is to always stick with vertex form unless you have some other reason to use standard form. Especially you have vertex form, you know the vertex, so you might as well start with this. So A equals H minus -1 squared. Don't forget about that square plus 8. I'm gonna simplify that a little bit. I think I'm just gonna make that A times X plus 1 squared. I recommend you start with that instead of X minus -1. And now we have to figure out A. How do we do that? Well, we realize that the y-intercept is 0, 6, or f of 0 equals 6. So now we could say that f of 0, I'm going to plug in my 0 plus 8, and all of this equals 6. I have this nice equation here I could solve. I have a plus 8 equals 6. I just found out that a equals -2, which means if anyone asked that this parabola is facing or opening downwards, no one asked, so it's just asking for the quadratic function. So I'm almost done here. Now that I have the a, I could go back, say, hey, here's my function. -2 times, and we keep that x plus 1. Don't forget the square plus 8. And I keep saying that because it's such a common error. People leave off that square. And if you leave that off, it's no longer a quadratic. That would be linear. It would not graph a parabola. For B, exact same thing. I'm going to think about that point as f of -1 equals -2. I'm going to start with the vertex form, but one thing at a time. F of x equals a times x minus 2 quantity squared minus 3. Now I'll plug in my point. If you really wanted to, you're welcome to plug in the point at the start first, but please make sure you are careful with your work because everything might just go away. So plugging in that -1. All this is equal to -2. I have a nice equation here. -3 squared is 9a minus 3 equals -2. 9a is equal to 1. A is equal to 1/9. So my function is a equals 1/9 times the quantity of x minus 2 squared minus 3. Don't forget to pause and re-listen if something's not making sense. Okay, one of the big reasons we study functions at all is to model real world behavior. So in this case, we're talking about a football. The figure shows when a football is kicked, the nearest defensive player is 6 feet from the point of impact of the kicker's foot. The height of the punted football, f of x, can be modeled by this function. You can read it for yourself, where x is the ball's horizontal distance in feet from the point of impact with the kicker's foot. And f of x, of course, is the height. Okay, let's do this. What's the maximum height? The function is a quadratic. A is negative, so the parabola opening downwards is definitely going to have a maximum. We could find out by plugging f of, no, we don't just plug that, right? Sorry. X is equal to -b over 2a. That's what I'm going to start with. So x is equal to -1.18 over 2 times -0.01. Now, this, in fact, there's a calculator here means, yes, go ahead and crunch these numbers on your calculator. I'm getting my calculator out right now to do that. And we have, and I'm also going to cancel the negatives, you know, why complicate things. 1.18 divided by, I'm going to multiply those in my head. 2 times 0.01 is 0.02. So I'm left with 59. So what does that 59 represent? Now that is the x value. That gives us the horizontal distance for the impact of the kicker's foot. We're looking for the height. So we have to plug that in. So f of 59 is equal to -0.01 times 59 squared plus 1.18 times 59 plus 2. Okay. On my calculator, I'm doing it. -0.01. And don't forget when you're doing the negative, you're using the negative that is under the 3. Don't use the subtraction sign. It will give you a error message. Plus, oops, plus 1.18 times 59 plus 2 equals 36, which seems pretty reasonable. 36.81. So max height is 36.81 feet. Okay. How far must the nearest defensive player, who is 6 feet from the kicker's point of impact, reach to block the punt? Okay. In other words, what is the height that the ball will be when a player is 6 feet from the kicker's point of impact? So all we do there is plug in the 6. We have f of 6 equals negative 0.01 times 6 squared plus 1.18 times 6 plus 2. Use my calculator for that again. Actually, what I'm going to do here is just a little trick. I'm going to go up and grab all that work that I have from before, because I did it all in one line at negative 0.01. I'll show you right now. No, I'll switch, see if I can switch to the calculator. Let's see if this works out. Nope, that's me. Hello, wrong camera. Gonna do it. Ah, no, it's not doing it. Let me see if I can get this working. Oh, I know what to do. I'm gonna take off my mic and switch to something. Okay, so there might be a little bit of issue with the sound here. Excuse me. Let's register this. Oh, there we go. Excuse the mess that I have there on my desktop. Get that out of the way. Okay, so I plugged that in. I don't want to redo all that, so I am going to, like, see, rather than retype it, I'm going to grab it by hitting enter. So see, that gives me something editable here. And I will type in, I think it's 6 feet that I want to do here. So I'm going to do 6. And then for this one, I'm going to delete just that one. And the same thing here, I'm going to do 6 and then delete that, because otherwise it would be a different number. Okay, so there we go. I don't have to do all the tedium of retyping the entire thing. And now I have my answer. So let me go back quickly to this guy. Okay, so 8.72 feet. So the football player would have to be able to reach a height of 8.72 feet if he wants to block the ball. Can he do it? I bet he could do it. He's probably athletic, and he's already pretty tall, and his arms already reach up pretty. Yeah, he could definitely block that ball as long as he's there when it gets there. Okay. If the ball is not blocked by the defensive player, how far down the field will it go before hitting the ground? Okay, hitting the ground is something you're going to see from time to time in math. And what that means is that the height is 0. So here, this is f of x is going to be equal to 0. So to figure this out, I'm going to take my function. It's right up there. So f of x is equal to negative 0.01 x squared plus 1.18x plus 2, and set this equal to 0. Okay. You have options here. If you want to use quadratic function and do a quadratic formula, you may to solve this. That'd be perfectly appropriate. If you want to try to factor it, good luck. I don't know if something like that is factorable. If you want to try to complete the square, that is possible, but we are using a calculator to do this. So I'm going to get out my calculator and see if I can make this happen. I have to do a little bit of erasing if you'll excuse me for just a moment. Go ahead and get your calculator. And pause this video for just a second. I didn't pause the video, I just paused the sharing. Okay, one moment. Okay, so sorry, I guess there was no delay for you. There was just delay for me while I paused the video. In order to solve this, I will be using my calculator. So go ahead and get out your graphing calculator. If you don't have a graphing calculator right now, you can use Desmos. It is definitely easier, but using a calculator is a skill you need without a doubt from any decent math course. So this is the beginning of that. If you don't have it, please make sure you get one at the student store or wherever you need to go to get one. You can get one online or on Target, but make sure you get the TI 84 plus CE as it says in the syllabus, TI 84 plus CE, that's color edition. Okay, let's see if I could switch to calculator one more time. Nope, that's me. What's going on here? Okay, here we go. We have it. Okay, so what I've done is I've gone to the y equals in order to plug in a function. So if I go there and type in my negative, remember negative is down here, 0.01, x is here, that button I'm pointing at right there, x squared, and I'm gonna hit that to square it, plus 1.18 x again, plus 2. Now the question was asking where this is going to hit the ground. So I have my function, I'm going to enter it, and I'm going to graph it by hitting graph. Okay, so what's going on here is that the parabola kind of looks like this and we can't see it. So I'm going to extend the graph a little bit. I'm going to extend this window by changing the window value. Now, right now it's going to 10 in each direction, right? The x min is -10, x max is +10, y min is -10, y max is +10. I really want to open it up so we see more over here. Now, remember the height, I reached the maximum height at 59, so 59 feet. So I'm going to go to like x max of, I don't know, like 120. I want to see pretty far that way. I also want to see pretty high up because I know the maximum we got was 37. That's why in order to see how high, to make this go higher, I'm going to change the Y max to, I think 40 should do it. 37 was the highest. And now if I take a look at the graph, I'm going to regraph it. There's the height. Okay, we can see everything. Can I see what? Oh, and we can even see where it hits. We can see where it hits the ground, but I think I want to open this up a little bit more. So I'm going to change my X max by going back to window. That's where all these settings were. X max instead of 120. Let's make that 150. Graph. Rewind that if you need to see any of that. Now you'll see some strange things going on here. What's going on with that X-axis and the Y-axis? It looks so fuzzy. Well, the thing is that it's marking every 1 unit. So I'm going to change that just to make it a little bit more comfortable. So I'm counting up to 150. How about I count by 25s, and that's going to be my X scale. And for my Y, since I'm counting up to 40, it wouldn't make sense to go up by 25s, but maybe 5s or 10s. And now let's graph that. Now it's not so crazy. So we can see that it's definitely hitting that up to that 37. We can see that it's a 5, 10, 15, 20, 25, 30, 35. Yeah, 37. That seems right. And that's happening after 59 feet. And we can see that 25, 50. So, or 57, whatever it was. I can't see my notes right now. I think it was 57 feet of horizontal distance. But the question is, what's the X value here? How do we find that X value? In order to do that, we're going to use this function in our calculator, this calculate to get there. You're going to hit second and then the trace button. That takes you to lots of different options that the calculator will do for you. In this case, we're going to find the 0. So I can either arrow down or I could just hit the 2 to go directly to it. Okay. So now it's going to ask for some questions at the bottom. Left bound. then it will ask for right bound, which means, okay, I know that my maximum is there. The calculator is dumb. It needs me to tell it every little thing. So left bound means I can go to the left until I'm just anywhere to the left of that upper point and hit enter. Okay, now it asks for the right bound. Notice it's put a line, it's like put a boundary there. I'm gonna go to the other side of that maximum. It doesn't matter how far I go. Okay, I'm on the other side. I'm gonna hit enter. And the reason it does this is because there may be several different maximums or minimums. So I have to tell it very, very clearly, even though there's only one. And now it's asking for me to guess. It's like making me do all the work, but it will give me the specifics. So I'm just going to put the cursor as close as I can to that top, just by moving left and right. Then I hit enter, and now it tells, I did the wrong thing. Why was I finding maximum if I'm finding a zero? Oh my goodness, that was crazy. It just told me that there's no sign change. There's no zero where I was just looking. I just went over exactly how to find the maximum. Sorry, it's been a long day. Let's try that again. I'm gonna go back to my graph. I'm gonna go back to calculate. Oh, vey. And calculate 0 is 2. Now I'm gonna look for my 0. I have to look over here. So when I'm doing left bound, I have to put my left bound somewhere to the left of that. So like that's enough to the left. And I also want to go to the right. I'm gonna do the same process, but I'm actually gonna go to the right of that 0. And now it's the same thing as guessing. There we go. So the ball will travel a total of 119.67 feet before it hits the ground. 119.6. Let's round to the nearest tenth. I think that'll be enough. See if I could change that to my notes. $119.67 or 0.7 feet. And of course, it's a word problem, so I'd expect you to write it will travel 119.7 feet before it hits the ground. Graph a function that models the football's parabolic path. Okay, this grid is completely inappropriate. I'm gonna make my own grid. I know that reaches a maximum, I think we said at 59 feet, so I'm gonna put that right here. I know it gets to a maximum of that 36, about 37. So I'll put that here. And we know that after 119, it's going to hit the ground. So that would be right here, 119. And one other thing we know from the original function, it's the standard form. We know two things. It's opening downwards, and that 2 represents the y-intercept, which means on this side, it's going to hit not the bottom there, but 2. And that's what I'd be looking for. Sorry about my squiggly line. That is a technological issue that I'm having here. Now, why does it start at 2? Well, because when you bunt a ball, it's not from the ground. It's from, well, in this case, 2 feet above the ground. Okay, moving on. You have 100 yards of fencing to enclose a rectangular area. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? Okay, now you may already know the answer for this one. And I'm going to plug my headphones back in until I need to use the calculator again. Maybe I can do both. No, I can't do both. But you may already know the answer to this. Please make sure that you are not doing this by intuition. Make sure that you are using math, specifically algebra 2. So we're looking for a maximum area, which means we're going to model this with a quadratic function. And we know that area is base times height. So let's model this rectangular region. Here's a base. Here's a height. The thing is, we have this area equals base times height. Those are 2 different values. Now, could our base be like 1,000,000 and the height be 1,000,000,000? Would that be okay? No, that'd be crazy. We have restrictions on our variables. Specifically, we have 100 yards of fencing. So what I do on the side is I'm gonna deal with the restrictions that we have here. And perhaps it makes sense that 2b plus 2h is equal to 100. That's the perimeter. Or we could say that just b plus h is equal to 50. I hope that makes sense, that if we just go half the way around this rectangular field, that would be 50 yards of fencing. Okay, so now rather than have two variables in my original function, that area equals base times height, I'm going to solve for base and say that base is equal to 50 minus h. And now I could go up here to say that we have 50 minus h times h. So area equals 50h minus h squared. Notice what kind of function we have here. It's an area function as a quadratic function based on height of this rectangle. How do we get the maximum area? Well, we find the h value that gives us a maximum area. So normally it's x equals negative b over 2a. Now it's h equals negative b over 2a. And the b and the a mean the coefficients of our quadratic function. So we have h equals negative 1. Oh, excuse me, negative, I fooled myself. Negative 50 over 2 times negative 1, right? This is our a, this is our b. So h is equal to 50 divided by 2, which is 25, which you may have already known. Maybe you guessed that that was going to be the maximum, the dimension that makes the maximum area. Guessing doesn't get you credit on a test or a quiz. I need to see this process. I need the dimensions, though, not just the height. So how do I get the base? Well, it tells us here that base is equal to 50 minus the height. So base is equal to 50 minus 25. The base is equal to 25. So the dimensions are 25 by 25, or base of 25 is 25 to give you the maximum area. What is the maximum area? We could plug the 25 back into the area function, or you could just say we have 25 by 25. That is 625 square yards. And I forgot to put the units up on here. 25 yards by 25 yards for the dimensions. Yeah, that's 7. Next. Example 8, among all pairs of numbers whose difference is 10, find a pair whose product is as small as possible. Okay, so we're trying to minimize something here. I need a function. I'll call this function P because it's a product. And the two numbers, X and Y. I don't know either one of them. Now, could I have like whatever numbers I feel like to make a negative product? No, there are restrictions on this numbers. So it's, the thing about these two numbers is that the difference is 10. So my restrictions say that x minus y equals 10, or y minus x equals 10. That would work too. Doesn't matter. I like to have everything in terms of x, so I am going to solve for y. Y equals 10 minus x. And now I can rewrite my function as x times 10 minus x. Okay, we have a quadratic function. 10x minus x squared. If you want to write that in standard form, just to make the a and the b a little bit more clearly visible to you, you may. We see that a is equal to the negative 1 and b equals 10. So I can do the exact same thing I'm looking for. The x value that will give us the minimum product. So x equals negative 10 over 2 times negative 1. That gives us 5. And if x is 5, then what does y equal to? It tells us right here. So y is equal to 10 minus 5. I think I did something wrong. Let me check something here. What did I do wrong? Negative b over 2 times a. Oh, oh my goodness. It's x minus 10, isn't it? Yeah, it's x minus 10. I got to switch this up a little bit. I'm so sorry. X minus 10, which actually makes sense because this is now something that has a minimum. The other way it was reversed. So I'm just fixing my stuff up there. I hope you caught that and you're yelling at the screen, you made a mistake. Because that's a big mistake. I apologize for that. It's from here, negative b, that becomes 10 over 2 times 1. So the 5 is still the same, but I think things are about to change when we get our y value, because now y is equal to 5 minus 10. Y equals negative 5. 1 needs to be positive, 1 needs to be negative for us to have a very small product. So what is the minimum product? Oh, well, first of all, find a pair whose product is as small as possible. 5 and negative 5 give us the smallest product of negative 25. There we go. For example, 8. But we are not done yet. More fun to be had. We have example 9 and example 10. Yeah, this is a long one. Accepted relationship between stopping distance d in feet and the speed of a car v in miles per hour is this function here on dry level concrete. How many feet will it take a car traveling 45 miles to stop on dry level concrete? Okay, well, there's a calculator here. So we just plug this in. D equals 1.1 times 45 plus 0.06 times 45 squared. Getting my calculator to work on this. I want to get back from that graph. You have to quit. We can see is right above the mode button near the top of the keypad. So you hit second, and then just to the right of second, you can see the quit. That will take you back to your register. So 1.1 times 45 plus 0.6 times 45 squared equals 171. It'll take you 171 feet to stop if you're going 45 miles per hour on dry level concrete. If an accident occurs 200 feet ahead of you, what is the maximum speed you can be traveling to avoid being involved? Use the graphing features on your calculator to help you answer this question. Round answers to the nearest hundredth. Okay, I'm going to put this back on calculator view. So give me just a moment. Hey, there we go. We're back. Okay, so for this one, I need to type in my function. Where do I type that in? Y equals right here. I'm going to erase this one by hitting clear. And although my variable is v, I'm not going to look for a v. This only accepts x as an input. So I'm just going to change that to x. 1.1 x, remember that's up here, plus 0, oops, 0.06 x squared. But there's my function. Let's see what happens if I graph this. Woo! Oh, that's crazy. Yeah, that's not a good view for this. What I'm gonna do here is I'm gonna follow the recommendations that it has in your packet right there. You see under the question, it has the window settings. So let's go to the window and just see if we can get a good look. X min is 0. X max is 70. If we're going from 0 to 70, now the book recommends we go by a scale of 1. I don't think that makes sense. Let's go by a scale of 10. Count up to 70. For Y min, it says to go from 0. Y max, it says to go up to 250. My, oh my. And let's make a scale of 10, like I said, not 10. Up to 250 with 10s, let's do the scale of 25. I know I'm a rebel for all that. And now I can hit graph, Hopefully we get something a little bit nicer here. Cool. Okay, so we have a little piece of the parabola that's going like this. This is everything that's in the first quadrant. Remember, x was equal to 0 and y was equal to 0. That's x and y axis there. Okay, we have to figure out where this parabola hits 200. So I'm going to hit this y equals, and what I'm going to do is I'm going to go down to y2 by the down arrow and just type in a 200. You know what this looks like, don't you? Going to be a vertical line. Let's see what it looks like there. There it is. Notice one is blue, one is red. Going back to y equals, one is blue, one is red. You can see which is which there. Okay, so what's happening here is this is how fast we're going and how long it takes to stop. The faster we go, the longer it takes to stop. And if I'm going this fast, I'm not going to be able to avoid the obstruction that's 200 feet ahead. The question is, how fast can I go such that it takes me 200 feet to stop? I'm going to say that again. How fast can I go such that it takes me 200 feet to stop so I don't hit whatever is 200 feet ahead of me? So in order to do this, do you know what we're going to do? We're going to use that function we used before. Calculate. So second in calc. In this case, we're not going to find a 0. We're definitely not going to find a maximum. We're going to find where these two functions intersect. 5. So this is a little bit different than the last time. Because we could have like 10 different functions at the same time, the first thing is the question is going to ask, or the calculator is going to ask when you have to find intersection, is, well, which curves are you talking about? So that's what's asking, first curve. Now, right now, y1 is selected. You could switch back and forth between the different functions by just going up and down. At y1, y2. Okay, so first curve, I'm going to select y1, hit enter. Y2, it automatically goes to the next one. I don't have to think about it. There are only two functions in here. Enter. And now it's going to ask me to guess. So I have to move my cursor so I can guess where that point of intersection is. Guessing it's right there, and I hit enter. And it now tells me I could be traveling along at 49 miles per hour in order to make sure I am stopped by 200 feet. That is the answer to that question. So you review that as you need to, but you do have to know how to do that intersect function, and all the calculation stuff happens right there when you have graphs on your calculator. Okay, going back to the normal sound I was doing before, the other microphone, and leaving the calculator behind. Give me just a moment to transition. Still here, give me just a moment. Just a moment. Okay, so we found out that answer, and I think I forgot to point it out, but the answer is at the very bottom of the screen. To nearest 49.29 miles per hour. Okay. Moving on from there. We have one more for this list. Oh, dude. Oh shoot. Okay, we're good. Sorry, I just had to plug in my computer because it was running green and talking. So okay, part C. We just did this. We just did this. Okay. I don't know what we're supposed to do in part B. It seems like it's the same thing. That's weird. Okay, lastly, a food truck Euro vendor has weekly fixed cost of $525 and a variable cost of $5.25 for each euro. Let me just make sure that this is recording sound. Check 1, 2, check 1, 2, 3. I lost the light in here. Just a second, let me move around. Okay, my motion sensor lights went out on me. Hopefully you can hear me better now. Hopefully you were able to hear me before. Check 1, 2. Check 1, 2. I'm gonna check on this one more time. Check 1, 2. Check 1, 2. Check 1, 2. Check 1, 2. Okay. I'm trusting that you could hear me. Am I showing the right thing? Yeah. Okay. Moving on. So we have this Euro food truck. Weekly fixed cost of $525, variable cost of $575 for each Euro combo prepared. So let X represent the number of Euro combos prepared and sold each week. Write the weekly cost function C for the food truck vendor. Hint, the cost function is the sum of fixed and variable costs. Okay. So if X is the number of euros he sells, well, first of all, he has to pay 525 just to keep the food truck going. But he also has to pay for each sandwich he makes. They don't come for free. So that's the cost he has to pay. The function R of X is equal to negative that, which describes the money in dollars that the food truck vendor takes in each week from the sale of X Euro combos. Of course, that R stands for, do you know what it stands for? Revenue, the money coming in. Use the revenue function and the cost function from part A to write the vendor's weekly profit function, P. So for profit, this is equal to the money that comes in, R of X, minus the costs that he has to pay. So we know both of these. P of X is equal to R of X, which is negative 0.001 X squared, plus 8.95x, and we subtract the cost function, 525 plus 5.75x, to give us, and there's not a lot of room here, I apologize for this, a grand total of negative 0.001x squared. I have to subtract 895 minus 575. I think that's 325x minus 525. So you use the vendor's profit function to determine the number of Euro profits that should be prepared and sold each week to maximize profit. What is the maximum weekly profit? Okay, now that we have our profit function, we want to find the maximum. Let's verify that it has maximum. Look at that. A is negative. It's opening downwards. It definitely has a maximum. So in order to find that value, we just do a negative b over 2a. 2 times negative 0.001. Did I write that correctly? Yes, I did. Okay, the negatives cancel. 3.25. I'll go ahead and use my calculator for this because it's been a long day. So 3.25 divided by 0.002. 1625, if I did that correctly. So X, that is the number of euros that they have to sell to make a maximum profit. What is the maximum weekly profit? Well, to do that, we have to plug in 1625 into our function. Negative 1.001 times 1625 squared plus 3.25 times 1625 minus 525. I'll work that out while you do it too on your calculator. See if you can beat me. Okay, I got it. He's making $2,115.63 because there are no half pennies. That's his maximum or his or her maximum profits. And that does it for today. That very long lesson. Thank you for hanging in there and joining me with this. And if you have questions, let me know. Thank you so much. Bye-bye.